Okay, so a single particle of light can have three totally different fates. Let's dig into what decides its destiny. And no, this isn't science fiction. It all comes down to how a photon interacts with matter in some really surprising ways. First up, let's talk about the lowest energy interaction. It's called the photoelectric effect. So for this one, just picture the photon as a tiny all-or-nothing bullet of energy. This little bullet hits an electron and bam, it transfers all of its energy. The photon itself is completely absorbed, poof, it's just gone. And that electron, it uses that energy boost to get knocked right out of its atom. Okay, so what happens if the photon has a bit more energy? Well, that brings us to fate number 2. This is called Compton scattering, and here, the photon acts more like a billiard ball. It smacks into an electron, but get this time it doesn't disappear. Instead, it's more like a trade. It just gives the electron some of its energy. So after the collision, both the photon and the electron scatter off in different directions. The photon actually survives this one. It just carries on with a little less energy than before. All right, now for the most dramatic one. This requires a really high-energy photon. It's called pair production, and honestly, this is where things get really wild. A super energetic photon gets near a nucleus and just vanishes into thin air. But in its place, 2 brand new particles are created from nothing but pure energy. You get an electron and its antimatter twin, a positron, that literally pop into existence. And this is a perfect example of Einstein's E equals mc squared in action. But it only happens if the photon has at least 1.022 mega electron volts of energy. So what's the one thing that decides which of these 3 fates a photon meets? Well, this chart kind of sums it all up. The photon can disappear, bounce, or become matter, and what it does all comes down to just one thing: how much energy it has. Yep, the photon's initial energy is the key. Low energy gets absorbed, but super high energy creates matter. So if energy can literally become matter, what other insane secrets is the universe hiding from us?